It's actually a circular sleeve, if you will, a collar that fitted around the entire workshop. This is what broke loose and started the whole sequence of tragic events that beset the Skylab mission. It's deliberately painted this way, by the way, to reflect heat from the sun's rays, and it was supposed to pop out 5 inches and provide a shield, if you will, or a buffer space, an insulation layer between it and the side of the workshop. That broke loose, of course, at 1 minute and 2 seconds into the launch, came unglued, tore away one of the solar panels, and created the electrical power. Now, if they can free the other solar wing this afternoon, we're going to give you an idea of what happens here, of how solar energy works. This is a model of one of the solar cells on board. This blue and white device here is a series of solar cells. There are actually 260,000 of them on each of the arrays. These solar cells are picking up light, in this case the ultraviolet light from our floodlights here at ABC Space Headquarters, and driving a small electric motor that turns this propeller. We can increase the power and show you how it goes up even more by pumping on this light, which speeds the propeller up enormously. That light has a higher infrared content. That's the whole secret of how Skylab is powered. It must have the sun, its solar cells must work, those solar wings must work, or the space station itself cannot work. And that's the rescue mission, prime part of the rescue mission Conrad, Kerwin, and Weitz have today, to try to free that panel.
Jules, when they actually go in to deploy the parasol, as it's now called, it's going to be pretty warm in there, isn't it? I heard this morning that the temperature on board the workshop was something like 120 degrees, and it's been higher than that in the last few days.
It's been so high, Frank, that they're going to use special smoke masks, such as miners use with their own breathing cartridges. When they get in there tomorrow morning, they'll be in flight coveralls, not the hard-pressure spacesuit. But they'll be wearing this because of toxic fumes that mission control and scientists fear have been given off, toxic fumes by the film, by urethane, polyurethane insulation in the spacecraft walls. Now, they've depressurized Skylab, taken it down to about 3/4 of 1 pound of pressure. It'll be repressurized tomorrow morning again just before they get in the hope of keeping it somewhat cooler and the air cleaner. But Conrad and Kerwin, they'll be Conrad and Weitz, I beg your pardon. As of now, will be the 2 men who float in. Kerwin will probably play safety man back in the command module. They'll wear these masks, work their way into the interior of the workshop, and try to deploy the parasol. And the estimated temperature in there when they go in will be anywhere from 90 to 125 degrees.
And it's going to take about an hour, too, isn't it?
It can take, one estimate is an hour. Some estimates run as high as 2.5 hours.
I read somewhere where somebody mentioned it'd be like working in the desert. But,
and it's very, very dry. It's exactly like the desert, right. As a matter of fact, another modification, it's so dry that Dr. Berry told us the other night, the astronaut's doctor, they're sending up a humidifier to dampen the place down because they fear the astronauts' lungs will become too dry and they'll pick up dust particles.
Well, I hope they're accurate in taking the temperature inside the orbital workshop when those fellows have to go in there.
Well, it's going to be a hot, dirty job, make no mistake about it, until they get the parasol or one of the other devices erected to cool it off. And it's a dangerous job in many ways.
And how long after the parasol is actually in position? In other words, how long before they get the shield out there? Will things begin to get livable inside the workshop?
The estimates they've made so far are that after you get the umbrella, the parasol erected, it will begin to cool down. It'll cool down to 90 degrees from the 125 roughly that it's been at. It'll cool down to 90 degrees in about 24 hours. But that's still not very livable. That's pretty hot. And they then estimate that it will take another 3 or 4 days, no one is sure exactly how long, to get it down to 75 degrees.
Let's listen to launch control now. Thanks, Jules.
Quick voice checks on their Astrocom circuit. Cryogenic topping continues. Swing arm number 9 in the standby position. It will be moved back to the full retract at T-minus 5 minutes. Now T-minus 10 minutes, 42 seconds and counting. This is Kennedy Launch Control.
Okay, not too much longer to wait now before the actual moment of liftoff. ABC News will bring you more on the first Skylab mission after this message. Jules, the weather, it seems to me, is improving, at least from our point of view, so we'll be able to watch this launch a little longer.
It looks like we should have good picture all the way through booster burnout, about 2 minutes and 10 seconds. And that good picture is important on this launch, which NASA didn't have on the last launch. Otherwise, it might have known, it might have known what happened, what went wrong with Skylab, why that meteoroid shield tore loose. So they don't want to take chances now.
Let's go to launch
control.
This
is Skylab Launch Control. We're passing the 6-minute mark in the countdown now. Various personnel now reporting into the spacecraft test supervisor, Bill Schick, that they are ready and go for launch. Bob Reed, the spacecraft test conductor, has indicated that the spacecraft is go. Launch operations manager Paul Donnelly reports go and the Director of Launch Operations, Walter Caprian, also has reported go for launch. Final computer programs are now being run to place the launch vehicle in a launch mode. In the spacecraft, the final actions to be taken there will be at the T-minus 4-minute mark. Paul Weitz will turn on the spacecraft batteries, and at T-minus 45 seconds, the last action to be taken by the crew will be taken by Pete Conrad when he makes a final guidance alignment. We're coming up now to the 5-minute mark. At that time, the swing arm number 9, will come back to the full retract position. Actually, for the Saturn 1B, there are only 5 swing arms. The number 9 designation comes from the earlier launches using this same mobile launcher using the Saturn V. The swing arm now coming back to the full retract position. It will remain in that full retract position now for the rest of the countdown. At T-minus 3 minutes and 7 seconds, the count will go on the automatic sequencer and will be carried out automatically from that time on. Now T-minus 4 minutes, 39 seconds and counting. This is Kennedy Launch Control.
And if it looks like it's another routine launch, it is and it isn't. In a sense it is, because it's another Saturn 1B, not that unusual a launch. In another sense, it's an extraordinary launch because NASA is up against the wall. Without Skylab, it lacks both the medical knowledge and the political arguments it needs to go ahead with its multi-billion-dollar space shuttle. If this rescue or salvage effort fails, NASA will have to delay the shuttle to get the $500 million extra it will cost to fly the backup Skylab, Skylab B, next year. It's kind of ironic, Frank, because Skylab started as a quiet little poor man's workshop, or poor man's space station, that almost got lost in the shadow of the multi-billion-dollar Apollo program. Mm-hmm. In many senses, it got the backup people, the secondary people. Its program management left something to be desired, and still leaves something to be desired, in my opinion, which is the reason we're in the trouble we're in now. Now NASA is up against the wall. This launch must succeed, or the whole space program stops cold in its tracks for the next year or two.
Yes, it's important to have this work successfully, or the shuttle is in some jeopardy.
Dr. Fletcher said so the other day. Chris Kraft has told her, we're looking at launch control now, and I can assure you this is a very nervous launch. In many ways, a lot more nervous than a lot of the Apollos to the moon that somehow seemed to get so routine, although they really weren't.
Well, of course, this mission has had its problems. Last time we were here, sitting at this desk, why we expected to come back the next day and see what is about to happen.
Control. The launch sequence has started. We are now on the automatic sequencer, and the countdown will be run now by that automatic sequencer. A number of functions are carried out by the sequencer, and they must be carried out in the proper order, or they would be automatically shut down. Also, at the same time, the launch crew here in the firing room will continue to monitor their various readouts, temperatures, checking the gauges for pressures and rates. They could override the sequencer if necessary. At the T-minus 3 minute and 6 second mark, the automatic sequencer terminated the liquid oxygen and liquid hydrogen replenishing. These cryogenic fuels had been being replenished since fueling was actually completed early this morning. After this termination, the fuel tanks will be pressurized. Actually, pressurization has now started. The second stage liquid oxygen tank has now been pressurized, and the first stage fuel tank also has been pressurized. Now passing the 2-minute mark in the countdown, the vents closing, and these pressurizations taking place on the 2 stages of the Saturn 1B. At the T-minus 1 minute, 15 second mark, Paul Weitz will trip 2 switches in the command module, placing the spacecraft batteries online. These batteries
I don't think launch control sees it yet, but a low deck of rain clouds has suddenly begun to move in, which is obviously going to obscure some of the view.
This time, T-minus 1 minute, 30 seconds and counting, and our countdown continues to go smoothly. Also, during the automatic sequence, we'll switch to internal power. We've been carrying the power from a ground source up to this point to save on the flight batteries. At T-minus 50 seconds in the count, we'll switch to earn internal power and stay on internal power for the remainder of the count. We're approaching the 1 minute mark in our countdown. Mark, T-minus 1 minute. 1 minute and counting in the launch of the first manned mission in Skylab. T-minus 50 seconds. T-minus 50 seconds and counting, and we are now going to internal power. All stages switching to internal power. Stages now and fuel tanks pressurized. Approaching the 30-second mark in the countdown. At 30 seconds, water will begin spraying on the deck of the mobile launcher. T-minus 30 seconds, and the countdown continuing to go smoothly. The Skylab itself orbiting some 780 nautical miles northeast of KSC at this time. T-minus 17 seconds and counting. T-minus 15. At T-minus 3.1 seconds, we'll expect the engine sequence to start on the vehicle. T-minus 7, 6, 5, 4, 3. Engine sequence start. 2, 1, 0. We have launch commit and we have liftoff. The clock is running and Skylab has cleared the tower.
Tower in Houston, Skylab 2. We fixed anything. We got a pitch and a roll program.
Houston is now controlling.
The thrust is going all engines. Boy, is that a smooth ride.
25 seconds, pitch and roll program started. Skylab now maneuvering to its proper flight path attitude. Mark 35 seconds, 1 nautical mile in altitude. Given a green by range safety. Mark 45 seconds, cabin pressure relieving, adjusting now from sea level to a space environment. Mark 50 seconds, 2 nautical miles in altitude.
And roll is complete, Houston.
Roger. Stand by for mode 1 Bravo. Mark, mode 1 Bravo.
Roger, propellant up is RCS command.
Roger.
Mark 1 minute 8 seconds, roll program complete.
Skylab Houston, your feet wet.
Roger, feet wet.
That call up from Capcom Dick Truly says Skylab now capable of water landing. 1 minute 20 seconds, passing through the period of maximum aerodynamic pressure on the vehicle. 1 minute 25 seconds, 8 nautical miles in altitude. Mark 1 minute 35 seconds, pass through max Q. Skylab still flying steady on all 8 engines.
Auto 2 now, launch vehicle rates are all off.
Roger. Stand by for mode 1 Charlie. Mark, you're mode 1 Charlie.
1 Charlie.
The status check and mission control by Flight Director Phil Schaffer. A go, no go for staging. Given a go for staging.
Houston, you're go for staging. You're looking good.
Mark 2 minutes 6 seconds. 21 nautical miles in altitude, 20 nautical miles downrange. Velocity now reading 5,947 feet per second. Coming up now on staging and shutdown. Center engine shutdown. 7 outboards out.
They got an S4B late, Houston, and a nice staging.
Roger that.
Mark 2 minutes 35 seconds, staging on schedule. Conrad, Weitz, Kerwin now riding on a good second stage engine. Coming up now, launch escape tower jettisons.
4B.
Tower, Houston on time.
Roger, tower jettison, you're mode 2.
Mark 3 minutes 2 seconds, 47 nautical miles in altitude. The launch escape tower now ejected. Reports Conrad, his crew safety roll no longer required. 3 minutes 12 seconds, 50 nautical miles in altitude, 84 nautical miles downrange. Velocity now reading 8,200 feet per second. Three minutes 25 seconds, the first stage and launch escape tower both falling away now, headed for their own splashdowns. Meanwhile, Conrad, Weitz, Kerwin now at 58 nautical miles. Skylab continuing to climb, moving out well beyond the Earth's atmosphere.
Okay, Houston, the computer looks good here.
Roger, we concur. CMC's go.
3 minutes 58 seconds, 66 nautical miles in altitude, 140 nautical miles downrange.
Houston, looking good. Go at 4 minutes.
And we're go here, Houston.
About halfway there.
The entire launch sequence will take about 9 minutes and 51 seconds before they are inserted into orbit.
15 seconds. Now it's 71 nautical miles in altitude.
Very sad because we didn't see very much. It disappeared into the clouds here at the Cape less than a minute after liftoff. Must have been about 30 seconds or so. There was a very low cloud cover at the time of launch at about 2,000 feet. Another broken level of 8,000, another broken level at 25,000, and we saw it for about a fraction of a second as it went through one of those layers about a minute and a half after liftoff, and I don't think we got it on the television. And a large camera that we have down the coast, which normally would show the staging and show the rocket for about the first 30 or 40 miles, could not get a picture either because of the cloud cover extending all up and down the coast of Florida this morning. But everything is going well on the launch, and they still have about another 4.5 minutes to go. John?
The rocket looked small when we saw it on the screen. Never saw one go in the manned spacecraft series that we've seen that looked that small, and it was, in fact, about 100 feet shorter than the normal big Saturn V that carried the men to the moon. And so it was smaller. It looked smaller. Business as usual at Cape Kennedy as the space program goes on. The Skylab 2 spaceship has burned about 9/10 of its launch fuel now at this moment and has traveled almost 1,000 miles. It will soon be in orbit in a minute or so. Jim Hartz is at the Cape.
John, they are at 89 nautical miles altitude, 522 nautical miles downrange. We are used to thinking of downrange as being south of Cape Kennedy. Normal launches go that way, but this one, as did the Skylab launch on May the 14th, is going north from Cape Kennedy, up along the east coast of the United States. I don't have a map with me, but I guess at this point it's probably around North or South Carolina, somewhere along in there, heading up toward Nova Scotia. The orbit goes up that way, down over the top near Great Britain, across Europe, Italy, the Mediterranean, and down toward the Indian Ocean. We've never had a manned launch in that direction before. And while we're waiting for them to get into orbit, they're okay. I just want to mention one little thing. If they had to abort on the launch, they had a special set of procedures so that they would not land in the North Atlantic, where the water is very cold. The spacecraft is not built for that. It could have withstood it, but they did not want to do it. And so they had a special set of procedures so that if something had happened during the launch phase, they would have been able to maneuver the spacecraft so that they would have come back to a more southerly latitude to land and be picked up. So several interesting things like that on this launch that we've never had to worry about before. Another thing, the rocket that they used was 8 years old. It was built way back in the 60s, the old Saturn 1D, but it performed flawlessly. Now let's listen and see just about now for the insertion.
Stand by for mode 4 capability. Mark, your mode 4.
Mode 4.
Mark, down there's 35 seconds. That mode 4 call up from Dick Truly says Skylab can reach orbit on spacecraft power only. 83 nautical miles in altitude, 950 nautical miles down range. Standing.
Shutdown, Houston, 25-825.
Roger, copy.
There's a 189.1 by 83.5.
Roger, looks good. Stand by.
Well, somebody was talking to me as I got the orbital distances there, but it looks like they just got right on.
S4B
Proper speed.
That was an initial reading from the onboard computer of 189 nautical miles by 83.5 nautical miles.
That's very close to where they wanted to be. The Skylab is in an orbit that's 270 statute miles, 234 nautical miles above the surface of the Earth in a nearly circular orbit. The astronauts aboard their spacecraft have been put into what's called an elliptical orbit. Its high point is 189.1, the low point 83.1. Being in that lower orbit, they are traveling faster than the workshop, and so they will, the reason for that is they have to travel faster to catch up with it in the rendezvous sequence. That rendezvous sequence is much longer than we've been used to before. On the moon missions, they rendezvoused in the first revolution. Back in the Gemini flights here in Earth orbit from Cape Kennedy, they performed some rendezvous in the first orbit. But on this one, there are two problems. One, being in this high inclination orbit that I was talking about before, going very far north, many of the tracking stations that were built in the early days of the space program cannot track the spacecraft that far north. They were built within 30 degrees of the equator because that's where most of the flights were carried out. All the flights were carried out. Those tracking stations were used for the moon missions, but they're just not adequate for this kind of orbit. So they are going to wait, in effect, for 5 revolutions and catch up very slowly, so they'll have a chance to get very good tracking data from the stations that they will pass over from time to time. And the rendezvous is now scheduled for this afternoon at about 5 o'clock.
Skylab Control Houston.
The Skylab workshop is, and you're going to be hearing that phrase used more and more. It's used by the astronauts occasionally. The workshop is the largest and most complex space vehicle yet assembled. It's crippled, but it's still got a lot of good equipment working on it. And before Jim Hartz left for Cape Kennedy, he prepared a report on Skylab, and we'd like to show you that report now. Skylab, Jim Hartz.
We're in Huntsville, Alabama, and I am inside a huge hangar-like building at the top of a superstructure that supports a full-scale replica of the Skylab workshop. It comes in 3 basic parts, and it's huge. To my left, on the right side of the screen, is the main body of the workshop. That used to be the 3rd stage of a Saturn rocket, of the kind that took Americans to the moon. It's not used as a rocket on Skylab. The engines have been taken out, and the inside has been outfitted for the crew quarters, the major storage area, and the area for many of the experiments to be performed. To my right, across the top of your screen, is the 2nd section. This is used by the astronauts to control the environmental sections, the oxygen, electricity, and various things they need to keep the laboratory going. And also it has in it the controls for the Sun telescope, which is the huge spidery structure that's hanging down on the left side of your screen. This section, the Sun telescope, is mounted up on top of the workshop, making a structure that will weigh 200,000 pounds at launch. Now let's take a look inside. First thing I want to do is to orient you. The view you are seeing is the one the astronauts will first see when they leave their spacecraft that's come up from the ground to join the Skylab workshop that will be in orbit around the Earth. I've come in through another hatch here that will be used for extravehicular activity later in the mission, and this part is an airlock. The floor, as you would see it from the ground, is this way, and the ceiling this way. Of course, in space, with 0 G, that won't matter at all. In this area, which by volume is already the biggest spacecraft ever sent aloft by the United States, is the control panel for the Apollo telescope mount, and also part of the environmental control system, the oxygen and other things that are needed to keep the astronauts alive in space. I'm standing in an airlock. As big as this looks now, this is still not the main body of the Skylab workshop. That's through this hatch, which is either, depending on whether you're up or down, it really doesn't matter in space, it's back that way, or as we're used to it on the ground, down there. This is the other side of that hatch. It leads from the airlock to the forward compartment of the main spacecraft. The astronauts will float down into here. This will be the 2nd room that they'll get into. A door has been kept for training purposes on the ground. That won't be on the main spacecraft. This room is the largest room aboard Skylab, and as a matter of fact, it is the largest room that's ever been sent into space. They'll actually fly around in here with maneuvering units, but mainly it's used for experiments and storage. In a ring around the wall, you can see 10 water storage tanks. In boxes above the water tanks are stored portable lights, pressure suits, tape recorders, charcoal filters, fans, lamps, and intercom boxes. Down here on this side wall Lockers containing camera equipment, TV cables, lenses, things like that.
In freezers and in cans at room temperature. Scattered around various places in the spacecraft are foot restraining units to keep the astronauts from floating away. Also in here, on that wall and on this wall, are two small windows in which the astronauts can place cameras and other pieces of equipment, sensors, infrared sensors, ultraviolet sensors, various other things to be a part of the Earth Resources program. And they will photograph, survey, and map 95% of the populated regions on the Earth. And here's how this works. In all, there are about 90 pieces of equipment on board Skylab and 270 experiments, some of them supplied by high school students. We don't have time to look at all of them now. You'll be hearing about them in the next 8.5 months while the program is underway. Now we want to go to the final level directly below us, which is the astronauts' crew quarters. You're now at the lowest level in the spacecraft, and if all the hatches were open, you could look directly from the crew quarters through the forward compartment, through that hatch, into the air tunnel, into the docking adapter, and into the spacecraft, a distance of about 90 feet. The entire Skylab structure is 118 feet long if you include all the ancillary structures. But a straight line goes from here all the way through it. Now, down here is the kitchen. And they keep the food right here. These cans. This is their table. The three astronauts will eat here. They don't need chairs, but they do need a form of restraint, and so they've devised this saddle-like affair. Again, with the foot restraints. You can lean back and be quite comfortable. The food is kept in these things that look like little pudding cans. Top comes off like that. And there's nothing in this, but food is very carefully measured, and very careful record is kept of the amount of food they eat and the water they drink, which is ejected from this little faucet. And there's a counter on the side that records how much water they drink. Food is stored in freezers and refrigerators on the side wall and in shelves on that side. Washcloths, towels here, and clothes and various things around there. Over here, they have a window, and they can see the Earth. Outside the kitchen now, here's the shower. Once a week, each of the astronauts gets to take a bath, take a shower. And this is the way they'll do it. Step inside this ring, which is really just a series of metal, it's like an accordion made out of plastic, metal rings. That goes up and locks up here. But since you couldn't see it if I did it locked, I'll put it back down and show you how it works. Got a little water nozzle here that works sort of like the one we had in the kitchen, and spray themselves with that, have a special soap. And since they're in zero gravity, water would just float around. If they dropped the curtain, they'd have water all over the spacecraft in no time, so they have a little system to clean that up. That's with this. It's simply a vacuum cleaner, and they'd clean off their bodies and clean off the edges of the plastic and drop it, and they'd be clean Saturday night. They get 6 pounds of water, which works out to about 3 quarts for each shower. And for the first time ever on a spacecraft, they'll have aboard Skylab a toilet. And it's on the wall, which catches everybody's eye the first time they see it. But in zero gravity, it could be on the ceiling. Doesn't matter. There's also a mirror, places to put towels. On days when they don't take showers, the astronauts will be able to sponge themselves or use a wet towel here at this sink to clean up. And here is where the astronauts sleep. Plastic. And drop it, and they'd be clean Saturday night. They get 6 pounds of water, which works out to about 3 quarts for each shower. And for the first time ever on a spacecraft, they'll have aboard Skylab a toilet. And it's on the wall, which catches everybody's eye the first time they see it. But in zero gravity, it could be on the ceiling. Doesn't matter. There's also a mirror, places to put towels. On days when they don't take showers, the astronauts will be able to sponge themselves or use a wet towel here at this sink to clean up. And here is where the astronauts sleep. Sort of like a sleeping bag hung on the wall. But again, in zero G, it doesn't really matter. It'll still be comfortable. It's about the size of one of those old Pullman berths. They have an intercom in here, various drawers and things for their personal belongings. There's a tennis shoe. And in here, tissues, clothing lockers down here. And there are 3 of these, if we can get out, lined up in a row down here. And the astronauts plan to sleep at the same time every night and structure their day around a typical day in Houston. That is, they'll go to bed at 9 or 10 o'clock each evening and get up and begin their days each morning at about 6 or 7. And finally, we want to look at a couple of machines that could have some therapeutic value, as well as giving the scientists on the ground valuable data about the conditions of the astronauts. Now, this machine looks like one of those bicycles that a lot of people have in their basements, or you find in gyms around the country. The astronauts will get on this thing at regular intervals and pedal it to stress their heart. Electrocardiograms will be made. Their breathing will be recorded through this. And from that, people on the ground hope to get some better idea of what happens to a man's physical condition while he's in zero G. This machine is unique. One of the problems in space flight is that the blood that normally would be settling to the lower part of a man's body when he's in a gravity field does not do that. And because of that, some scientists feel that the heart, lungs, and the entire cardiovascular system doesn't function properly, and that there's some deterioration in it. So on this flight, the astronauts periodically will get inside this machine. What it looks like is one of those old iron lungs, and then patch this up just about around the waist, and then air will be withdrawn from this, which will create a partial vacuum. The scientists believe that that will pull the blood down to the legs and feet and simulate gravity as it is on Earth. Precise measurements of what happens to men's minds and bodies during long periods of isolation and weightlessness will have a profound effect on the future of manned spaceflight in this country. The results from Skylab will go a long way toward determining whether it will be possible to, perhaps by the year 2000, have permanent manned orbiting stations around the Earth, and perhaps venture to Mars and beyond.
Jim Hartz taking us on a tour of an unusual vehicle. The Skylab 2 command service module is winging its way around the Earth, and we'll go for a report on it. We'll go to Roy Neal at the Manned Spacecraft Center. Roy?
Yes, John. A few moments ago, as they were coming up over Europe, Pete Conrad told astronaut Dick Truly in Mission Control, as we're coming up over Europe, I've never seen so many contrails in my life. And Truly in Mission Control came back and said, well, I trust you're higher than all of them. And Conrad said, I hope so. Now, they're out of contact right now. They've just passed over the Madrid tracking station. Have gone out of contact for some 30 minutes. When next they'll be heard from here in Mission Control, it'll be as they come over Carnarvon, Australia, moving well. As a matter of fact, other comments from the astronauts indicate they have indeed separated well from their S4B or rocket stage. They're now climbing slowly above it. The S4B stage is described by the astronauts as very stable. Now, in Mission Control at this time, we have 2 teams of flight controllers, one monitoring the orbiting workshop, the second team following the astronauts in their command module. And there's a lieutenant commander by the name of Dick Truly talking to that all-Navy crew, Captain Pete Conrad, Commanders Joe Kerwin and Paul Weitz. At launch time, the spacecraft, the orbiting workshop, rather, was about 750 miles downrange at an altitude of around 234 nautical miles. So now the astronauts will play a game of catch-up, going through a complicated series of maneuvers as Mission Control monitors those maneuvers for the next few hours, so that finally, in the fifth revolution, about 7 hours from now, they can rendezvous, and then they hope to fly around the workshop. And that's when they plan to send back some television pictures so that these men in Mission Control can take a good look and assess the damage done when that shield blew off some 11 days ago.
Roy, John Chancellor.
Yes,
they will be some, I think we ought to remind the audience that the astronauts will be out of touch at various periods of the day while they're working and living in Skylab. Could you amplify that a little bit for the audience?
Sure can, John. Matter of fact, Jim Hartz made a rather good explanation a few minutes ago, and I'm just going to quote Jim. In essence, what you're looking at here is the most northerly orbit that the United States has ever put men in. What that means in terms of ground tracking stations is that there are long periods of time when there is no tracking station able to communicate with the spacecraft. There are also a relatively small number of tracking stations, and so right now we're seeing a good sample of that.
Jim Hart, we had a modified spacecraft that went off this morning. Did they get all the things aboard it, stowed aboard it, that they wanted to?
Right, we didn't have time to talk about that very much before the launch. They put aboard the sails that we were talking about, the covers. They had to take a few things out. They also put some extra fuel aboard, which is for their power generation. It was the heaviest command module ever launched. It weighed over 13,000 pounds. And they just tied these things down with ropes. It apparently was a kind of an interesting sight inside there. Never seen anything like that before. John?
Thank you, Jim. Well, they're on their way to save a $294 million laboratory up in space that's the key to a $2.5 billion